Assalamualaikum and hi. My name is NURHADIRAH binti Abdul Hadi and my metric number is 300840. Today, I will explain 5 key topics related to regression. First, the historical origin of regression. Second, statistical versus deterministic relationships. Third, regression versus causations. Fourth, regression versus correlation. And the last one is simple versus multiple regression models. So let's get started. For the first point, for historical origin of the term regressions is the words of regressions come from the work of Sir Francis Galton, which is he is an English scientist in the late 19th century. He studied the relationship between parents and children's height and found that very tall parents tended to have shorter children, while very short parents tended to have taller children. This pattern showed that extreme values move closer to the average height in the next generations. Galton called this phenomenon regressions to the mean. Today, the term of regression is used in statistics to describe mathematical models that analyze relationships between variables. The next one is statistical versus deterministic relationships. A deterministic relationship means that if it has one variable, it can exactly predict the other without any error. For example, the circumference of circle is always 2 pi r. There is no variation because the relationship is fixed by mathematical formula. However, a statistical relationship is involved some uncertainty or randomness. For example, studying for more hours tends to increase exam scores, but the exact score is influenced by the other factors like sleep, stress, and test difficulty. In statistics, we deal with statistical relationships because most real-world data is affected by multiple factors and natural variations. The third one is regressions versus causations. Regression analysis help us see the relationships between variables, but it does not prove that one variable causes another. Just because two things are related does not mean that one is responsible for the other. This is because there could be hidden factors, which is confounding variables, influencing both variables. For example, a study might show that ice cream sales and drowning rates increase at the same time. However, eating ice cream does not cause drowning. The real reason is that hot weather increases both swimming activities and ice cream consumptions. To prove causations, we need control experiments or deeper statistical analysis that accounts for all possible influencing factors. Without this, regressions can only show association, not direct cause and effect relationships. The fourth one is regressions versus correlations, which is both regression and correlation measures relationships between variables, but they have different purposes and interpretations. Correlations measure the strength and directions of a relationships between two variables. It is expressed as a value between -1 and 1, which is a positive correlation means both variables move in the same directions, and vice versa for negative correlations. However, correlation does not imply causations, meaning that just because two variables are related does not mean one causes the other. Regressions, on the other hand, goes beyond correlation by describing the relationship and predicting outcomes. It helps estimate how much the dependent variable changes when the independent variable changes. Linear regression model. For the simple linear regression, it looks at one independent variable and one dependent variable, which is the formula is y is equals to b naught plus b1x plus e, where y is dependent variable, x is independent variable, b naught is intercept, b1 slope, and the last one is e for the error. And the multiple linear regression extends this by using two or more independent variables. For the formula is y is equals to b naught plus b1x1 plus b2x2 plus b and xn plus e for the error. And that's all from me. Thank you.